On from adding and subtracting, the next logical step is solving equations by multiplying or dividing. So let's start off like always and talk about our I can statement. By the end of the lesson, we want to be able to say, I can manipulate and solve equations by multiplying and dividing. Okay, so our first two definitions are here. The multiplication property of equality, very similar to the addition property of equality as well as the subtraction property of equality. If you multiply both sides of an equation by the same number, the two sides will remain equal. And the same thing is true for the division property. If you divide both sides of an equation by the same number, as long as you're not dividing by 0, then the two sides remain equal. So basically, to sum up, our multiplication property, our division property, and our addition and subtraction property, all you have to remember is that as long as you do the same thing on both sides of your equation, then your equation is going to remain true. And that's something you're allowed to do. Okay, it's mathematically sound. So let's come down and let's try an example here. X divided by 4 equals 24. Okay, just like in first grade, your teacher said, well, maybe not in first grade because this is a bigger number, but your teacher said blank divided by 4 equals 24. Some of you guys who are quick in your head with your math skills might be able to say, oh, I know X. I know it right off the bat. Okay, some of you are thinking, no, I'm not so sure about that. Division by 4, that's going to be a pretty big number. So, just like yesterday, when you had a number plus x plus 4 equals 10 and you wanted to get x by itself, you did the opposite of adding 4 and you subtracted 4. Well, same thing's true with multiplication and division. The opposite of dividing something by 4 is multiplying it by 4. So I'm going to grab my red right here, and that's what we're going to do. We are going to, we're going to multiply both sides of our equation by 4. Draw my line. So right now you have x divided by 4 times 4, and we better show it all. Okay, so x divided by 4, so you can see this. X divided by 4 times 4 equals 24 times 4. And since you've multiplied by 4 over here, you guys remember cross multiplication says, hey, I can cancel these two 4's out. Divide them both by 4, and what do you have left over? You just have an x. Okay? We just got x by itself. That's the whole point of multiplying by 4, is so that we can eliminate this denominator and just end up with our x by itself. And then all you have to do is some simple multiplication. 24 times 4. Well, 4 and 4 is 16. And there's your answer. X is 96. Folks, how do you check your answer? Okay, remember, you take your answer, you take it back to the original problem, you plug it in for x. 96 divided by 4. It is 24. You can check that with your long division, so it does check. That's your correct answer. So remember, over here we always give you the general case. It says for any numbers a, b, or c, as long as the left side equals the right side, as long as a equals b, then a times c equals b times c. Notice it doesn't tell you what c is. You just know c is some number. So as long as you multiply both sides by the same number, the left and the right are going to remain equal. Alright, down to the division property. Let's try our example down here. As we set up above, in order to get the variable, in this case c, by itself, you're going to want to do the opposite of what you're seeing. So since we see 7 times c, in order to undo that 7, we're going to want to divide by 7 here. Okay, because when you divide by 7, your 7's will cancel out, and you'll just be left with c. But don't forget, folks, whatever you do on the left side of the equation, you have to do it on the right side. So I must divide the entire right side by 7. And most of you are thinking, this isn't too bad. A negative divided by a positive better be a negative answer. And 56 divided by 7 leaves you with 8. So your answer should be C equals -8. In case you're forgetting, the check, which you should do every single time you solve an equation, you should know that you're getting 100% when you turn your paper in. Go back to your original. 7 times -8 is definitely -56. Alright, so let's continue on. And here I have example 1. So same type of thing as above. I'm going to let you take a second, try and do this on your own, pause me, and then come right back. Alright, in order to get x by itself, right now x is divided by -5. And we want to get x completely by itself, so I want to undo this division that is happening right here. So the opposite of division is multiplication. So I'm going to multiply the left side by -5. And then, of course, I have to do the same thing on the other side if I want to keep this equation true. I need to keep the equation balanced. So when I multiply by -5 over 1 on the left side, my -5's, of course, cancel out. And I'm just left with x. And then on the other side, I have -5 times -12. Well, a negative times a negative is always positive. So it's just 12 times 5, which is 60. Guys, you need to show all of this work. All of it. The sloppier you are, the more likely it is that you're going to make simple mistakes. Anytime we solve equations, you need to show your step-by-step process. Anytime. I'll show you exactly what I mean here in number 2. But you try this one on your own. Okay, here we are. We've got 8 times x equals 72. I would like to get x by itself. Since currently x is being multiplied by 8, I really want to eliminate that 8. Okay? So I'm going to divide by 8. This is showing my work. Because 8 divided by 8 is just 1. So you're going to be left with 1x. And I've got to do the same thing on the other side as well. So I'm going to divide by 8. I'm showing my work. Okay, I'm left with x, or 1x, however you want to think about it, equals 72 divided by 8, which is 9. Does that check? Let's see over here. Well, here's 8. You're going to plug in 9 for x. Seems kind of silly to write this out because this part you can do in your head, but it's good to get in this habit because when you get more complicated equations, you're going to actually have to show your check for sure. So 8 times 9, it is 72, so that checks. So we know we're right. Alright, here we have Esteban. He spent $112 on boxes of baseball cards. If he paid $14 per box, how many boxes of cards did he buy? So before you freak out about there being words, let's ask ourselves, what are we being asked to find? How many boxes of cards did he buy? That's what we're looking for. So since we don't know a certain number, like I said yesterday, normally we're going to let that thing that we don't know, it's going to equal a variable. So x equals, let's see if I can get this pen working here. X equals number of boxes of baseball cards. Remember, the thing that we don't know is always going to be our variable because a variable represents a number that we don't know. But once we set up an equation, we'll be able to solve for the variable like we've done up here, and that'll tell us how many boxes of baseball cards he actually bought. So, he spent $112 on baseball cards. So in total, he spent $112. And it says he paid $14 per box. Guys, in case you don't remember, per means multiplication. Okay, so you spent $14 on one box, $28 on 2 boxes, $42 on 3 boxes. So you're kind of getting the picture. $14 times however many boxes of baseball cards he bought, 14 times x, must equal the total amount of money that he spent. Okay, 14 times blank equals 112. And then just like up above, we know how to solve this. All we want to do is get the variable by itself so that we can figure out how many boxes of baseball cards he bought. So this is 14 times x. So of course you want to do the inverse. You want to do the opposite of multiplication. You want to divide. So we're going to divide the left side by 14. We're going to divide the right side by 14. 14 divided by 14, of course, is just 1. So you're left with 1x, or just x. And, long division time. 112, this is really tough on the Mimia, let me tell you. 112 divided by 14, that didn't help me much. You're going to have to believe me when I say x equals 8. Okay, x equals 8 boxes of baseball cards. Notice I showed all my work. So that if you got it wrong, you can go back and look and see where you went wrong. By the way, let's check this. Is 14 times 8 112? It better be, otherwise you did something wrong. 8 and 4 is 32. Take the 3 up, that's 8, that's 11. Look at that, it checks. So you are good to go. Alright, couple of reminders. When adding or subtracting to isolate a variable. Oh, I left your old notes on there. But it's the same thing for multiplication and division. When multiplying or dividing to isolate a variable, you must multiply or divide the same thing on both sides of your equation, like I already said at the top of the video. This is just a reminder. Okay, same thing. Always check your answers when you solve an equation. And I should probably add a third reminder. Always show your work. If you notice, in all three of these examples, I showed my step-by-step work so that when I get one wrong, I can go back, check it out, and say, oh, this is where I went wrong. Okay, next time I solve one of these equations, I'm not going to make the same mistake. As long as you're learning from your mistakes, you're improving.